Alright, to begin, we're going to go up here and make a new electrical sheet. Now we're going to make a boost converter here. So we're going to go under our analog library and start with voltage sources. So we're going to put one here and we're going to put a pulse here. Now to add the values, we're going to make this one's VDC 100, and for the pulse, its initial value will be -5, its pulse value will be 20, its rise time will be 0.01 U, and same as its fall time. So we can also find an inductor up here and put that there, give it a value of 25 U, and we want to measure the current coming out on this side, so we're going to put a current meter facing that way, so measure that. Now we need a MOSFET, so we're going to go down to our silicon carbide library, and for this demonstration we're going to use the CMF 10120. We're going to put that right there. Now we need a couple resistors, so we're going to go back up to the analog library and select resistor. We're going to put one here, and we're going to put one over here as well. Now we're going to replace these with a power resistor, so we can get these RTH, CTH values for the heating. Now we're going to give this value a 60, and we're going to give this value 0.01. Alright, now we need a diode, so we're going to go back down to our silicon carbide library and select the silicon carbide Schottky diode. Alright, now we want to measure the voltage on this net coming out, so we're going to put a voltmeter, or voltage probe, right here. And we're going to finish up with putting a capacitor here, give it a value of 2U, and a ground. Can't forget about the ground. Now we can use the wiring tool up here to connect everything. And I'll be right back after I finish connecting all of the devices. Okay, once we finish wiring it up, we can now select an analysis. So we're going to go over to our analysis folder, and for this we're going to select a transient run. So we're going to put that down, and we're going to give it a 100 end step, and for an end time we're going to do 300 U. So now that we made the electrical circuit, we can simulate it by coming up to our SPICE tab up here and selecting Create SPICE Netlist and Run. Alright, and save. Alright, and as per our current meter and our voltage meter, we have our current curve and our voltage curve. Alright, now because silicon carbide devices have a tough time with self-heating, we're going to demonstrate how we measure and simulate. So we're going to insert a thermal sheet here, and we're going to import our electrical components via heat sources here, the diode, MOSFET, and both resistors. Alright, now we're going to create a thermal circuit with thermal coupling real quick. Alright, so we can now go down to our thermal library and find a thermal resistor. We're going to put one for each heat source here, as well as 2 on the side and 2 in the middle for heat coupling. And now we can grab our thermal capacitor, put them next here, and for each resistor we're going to change the value to 0.1, and for each thermal capacitor we're going to change the value to 1.51 E -5. Alright, and I'll be right back once I finish doing that and wiring up the circuit. Alright, once we've wired up our thermal circuit here, we can now add the finishing touch, the ground. Alright, put that for each one here. And now we can simulate both our electrical circuit and our thermal circuit with coupling concurrently. And to do that, we go up here to our thermal tab and select the option Create Thermal / Electrical Netlist and Run. And what this does is combines the electrical sheet and thermal sheet into one. Alright. Little laggy due to the screen capture, but that's alright. Gonna get rid of the current and voltage curves you already seen, and we can now take a look at the junction and case curves. To distinguish these a little more, we're going to put the case curves onto one plot, or one pane, and the junction on the other. Now, as we can see, this is our R3, our resistor, our R2 curve actually, and this corresponds to this resistor right here. Right, and here's its respective case. Alright, and now we have our MOSFET's junction curve and its respective case, of course corresponding to our CMF 10120 here. Next we have our diode in the purple and in the teal, corresponding of course to the silicon carbide Schottky diode up here. And last but not least, we have our resistor R1 junction and case, which corresponds to this resistor here. Right. And this concludes the demonstration. Thank you all for watching.